What up? Today we're doing pipes. Pipes are, for some reason, I would hear about pipes when I was in school. People would say, "Oh, you pipe this into that," and for some reason, I thought it was some weird, complicated Linux computer magic, and I never really looked into it. I kind of was able to scoot by without knowing what pipes were. I just never really used them, but it turns out they are stupidly simple. I don't know why I overcomplicated it. I think that was maybe just me. Anyways, let's get right into it. Pipes are used to give the output of one command as input to another, or, in other words, use the standard output of one command as the standard input to another. And the character is that straight line thing. I don't actually know what the name is for that. We'll just type it out in a second here. But I have this little picture up here, and I don't know if this will help anyone. I don't know why the quality is so bad. But you have a process, which can be a command, and it has your standard out. So you can list, like if you do ls, it'll list a bunch of files and directories. That's the standard out. And you feed it into the pipe. The pipe spits out the standard input to process 1. So the standard output of process 0 is fed to process 1 as its standard input. So let's see how this works. The syntax is you have command 1, and then you do, that's the pipe character, command 2, and you can do as many commands as you want. You can pipe an unlimited amount of commands. And a simple one we can do is, so we'll list. So we know the list dash a, that's all. We know that command. It just lists everything, including the hidden directories or files with the period in front of it. Let's say for this, we only want to list things that have bash in it. So if it has, like this has bash, this has bash in it, this has bash, just these 3 files. We don't want the rest of these, only things with bash. What we can do is we can do a list dash all like before, and then we use a pipe. And then we'll do grep bash. So what this is doing is it's doing a list all, which we did up here, and this is the output, or the standard out. And this standard output is then fed into grep bash. So grep bash is looking for anything with bash in it. So it'll take this whole output and do a grep bash on it. So if we click enter, we see we only get things with bash in it, which are these 3 files right here. And we'll clear the screen. And another example is we can do ls. So let's do a normal ls. We have all the, these are all directories, and it lists all these directories. And what if we want to sort them? So we can do ls type sort. So this will do a list, like we did up here, and list all these. But then it feeds it into sort, and sort will list these again, but alphabetically. So we can see C, D, M, P, this is alphabetically. So it just takes all the directories and says, okay, this is the input, sort them, and then spit it back out. Another example is we can change directory into code notes. And so we have SpongeBob, we can cat this. It's Gary Come Home, it's that song in SpongeBob. But it's a pretty long text file. If we want to get the word count of that, we can do cat SpongeBob, and then we can pipe it into word count dash W. And that just counts the number of words in the output. So cat SpongeBob.text will display that whole SpongeBob Gary song, and then it's piped into word count. So the input to word count is the output of this, and it counts the amount of words. Cool. We also could have just done word count dash W SpongeBob.text. But this is just another way to do it, just an example. A more realistic use of pipes are, so we have this file called logfile.txt. We can cat it to see what we got. Oops. And it just looks like your typical log file. It looks like some server starting. It says server started successfully. Some user logged in. You have a failed login attempt. It has the IP. It has an error right here. So this log file could be really long. We only have, 20 lines or whatever, but this could be a massive log file. Typically log files can be pretty big. What we can do is say, okay, let's only list the lines where we have an error. So we have an error right here, we have an error right here, we have an error right here. These might be the most important for us because we want to know if we're having an error and what they are. What we can do is we can clear the screen, we can do cat log file like before. We can do a pipe, and then we can do grep, and we're going to look for anything that says error. So again, cat log file.txt is going to output that log file we just saw, and it's going to pipe that output. So the output of this will be the input into grep error, and grep error just looks for any line with the word error in it. So enter, and we get three lines of output, and they all have error in it. So error cannot connect to the database, error failed to load configuration file, error cannot write to log file. This is useful if you want to see your errors, because oftentimes those are the most important lines in the log file. And this is more of a, again, realistic use case of pipes. Redirection is used to redirect the standard out or standard in or standard error. Typically, redirection is used to write some output to a file. You can also redirect input. And the difference with redirection and pipes, or I guess pipes are a type of redirection, but pipes are mostly used to direct the output of one process or program to another. Whereas redirection, you're typically taking the output of some program or command or whatever and writing it to a file. That's typically what you use it for. Let's just go straight into some examples. So we can do a list, and we'll list right here. We just have these things. And what we can do is, let's say we want to list this and then write these to a file. So we can do list and then direct this or redirect this to, let's call it output ls.txt. So this will say, okay, list the contents of the directory we're in, but the standard output is this right here, right? The standard output's printed to the console right here. But instead of doing that, let's redirect that standard output to this text file. So if we run this, we're not going to see this outputted to the screen again, but it will live inside this text file. So run it. Okay, ran it, nothing happened. Perfect. So we can ls, we can cat output underscore ls.txt, and this is going to have, I mean, we made this new file, so it has it now, but this outputs everything that we would see if we did a ls. Cool. So a thing to note with this type of redirect is this file right up here, this didn't exist when we ran this. So if this file, if we do ls redirect it to this file, if this file doesn't exist, which in our case it didn't, it'll create it. If it does exist, the contents will be overwritten. So you have to be careful with that. Something we can do about that, let's say we don't want the contents to be overwritten. We can do, let's do an echo, and then we'll do, I don't know, we'll make up a fake directory. And then we do two of these, and we'll do it to the same output underscore ls. So if we just did one of these, actually let's just do one. If we just do one of these, what it'll do is this will be overwritten. And remember, this contains this right here. So if we do this, and then we do a cat output of the list, it just has directory 2. It's just a fake directory. Let's run that ls command again right here. And we can cat output underscore ls. So if we don't want to override it, what we can do is, again, we'll do echo, and we'll do directory 2, and then we'll do two of these. And what that says is, okay, don't overwrite the file we want to redirect our output to, but append to it. So we can do output underscore ls, and then we'll cat output ls, and it appends it to the bottom. So if we just did one of these little guys, it would, as we saw, get rid of this, override it, and only have this as the content. But since we did two of these, it appends it to the end. And we can also go in the other direction, so let's do a list. Okay, so this output file we just made, let's sort it. So we'll run a sort, and then we'll feed outputs underscore ls into the sort. So this will take, okay, what we have inside of output ls, which we just saw, direct that as the input into sort. So I run this, and it sorts it alphabetically. This outputs.py, let's nano into it. We use this in the one of the last videos, but let's just go over it again real quick. So what this does is it takes user input, and it should be a name, and it checks if it's a valid name or not. And It's a pretty basic program. It's an invalid name if it has any numbers in it, and if it doesn't have any numbers, it's a valid name. It's not the best name checker, but it'll have to do. So if it's a valid name, it writes to standard output. So it says hello, whatever their name is. If the name's invalid, so it has a digit in the name or multiple digits, it writes to standard error. And it does sys.standarderror.write. That's how you write to standard error in Python. And it says invalid input. So let's give it some input. So I'll do user input. I'll do my name, Ryan. We'll save and exit. And so let's run this. Let's clear the screen. Let's run this. We can do Python 3 output stop high. So what this says right here, it says, okay, run this Python file, take the standard output and standard error. So this is saying take both standard output and standard error, which is why we call this outputs and error, and redirect it into this text file. So we'll run this, and we'll cat this text file we just made. Outputs. And so it says, hello, Ryan. So if we go back into the text file, we do Ryan, and let's just do a bunch of numbers, which, again, that means we have standard error. We can have numbers. And we'll exit. Run that same Python file, and we'll cat outputs. And we can see the standard error is also directed to that text file. Now, you might want to only capture standard error. You might not care about, the typical output. That means everything's running correctly. But you might want to say, okay, capture the standard error and put it in a log file, just so I can review it later. What you could do is you can do the same thing, except instead of the ampersand, you do a 2. Now, as a reminder, the 2 is the file descriptor for standard error. So basically 2 just represents standard error. So this is saying, okay, this means we have standard error originating from this Python file. And if that's the case, put it into this text file and let's rename it. Let's just we'll call it error_log.txt. So we'll run it and it should have the error message. Cool. Now if we nano back into the Python file and we do some normal input, that's not going to cause an error. So just Ryan. Save, exit, run the Python file again. Cool. And so see how it actually printed hello Ryan to the screen? This is because we ran this and said, okay, if we get an error, redirect it to the log file. Well, we didn't get an error. We had valid input. So it prints it to the console. So the standard out is directed to the terminal. And if we cat our error log, we have nothing in it. That's because this wasn't directed to it because it's not an error.